Waves that hit Australian coastline contain 5 times more energy than Australia needs on a daily basis. However, of course, not all of that energy can be converted into electricity if we take into account available technologies, presence of the power lines, and distribution of the population along the coastline. At the University of Adelaide, we work on the development of control systems for wave energy converters that maximize their power production and protect them in extreme wave conditions. And we see this as an opportunity to combine both technologies for cheaper and more reliable offshore energy production.
China has experienced rapid growth in offshore renewable industry. Individual model has scaled up from 1 megawatts to almost 20 megawatt scale. Our installation capacity arrived from pre-commercial stage to the leading position in the world. Besides bottom-mounted wind turbine, there are also 2 floating offshore wind turbines in China. In Shanghai Jiaotong here, we are very lucky to be involved in several key R&D process in above project. In particular, at this moment, we're working with several industry partners to advance the technology and development, in particularly the design of next generation offshore renewable system.
The Australian-China Joint Research Center of Offshore Wind and Wave Energy Harnessing was established to explore the synergies in integrating offshore wind turbines and wave energy technologies, with a goal to address the common challenges faced by ocean renewable energy industries and contribute to the global carbon neutralization. The Joint Research Center was led by the University of Adelaide and Shanghai Jiaotong University in partnership with governments, research institutes, and offshore wind and wave energy industries across the 2 nations.
The Australian Maritime College led the experiments into the co-located wind and wave devices in the JRC. The purpose of the experiment was to evaluate if a wave energy converter could reduce the wave loading on an offshore wind turbine in operational and extreme conditions. The data that was collected was used to validate a range of numerical models and was recently published in a highly recognised journal. The AMC experiments were the first in a series where we evaluated the hydrodynamic interactions of the devices in intermediate conditions, whereas our partners at Shanghai Jiaotong University are conducting a similar experiment in deeper water conditions.
Twin tank at Shanghai Jiaotong University is 300 meters long, 60 meters wide, and 7.6 meters deep. We have advanced equipment such as high-speed carriage with a speed up to 10 meters per second, 0.1% accuracy. We also have multi-element wave generating system, can make a variant of waves to test the offshore wind and wave energy units under extremely large wave conditions.
My research aims to understand the physics of extremely large waves acting on offshore wind turbine structures and make more accurate predictions of wave flows, and finally to reduce the cost of offshore wind energy. I have developed efficient methods to predict more accurately the wave load and to produce new scientific knowledge on wave effects on large offshore structures.
My research in the GRC is to investigate numerically and experimentally how the motion of the wave energy converter can be controlled to simultaneously maximize its power production and minimize the wave loading on the wind turbine substructure.
My experience with the JRC colleagues and research partners was excellent. There was plenty of healthy discussions about the experimental progress and interpretation of the data. This was important as I was able to discuss technical challenges with researchers who had first-hand experience. Collaboration contributed to the great outcomes that we achieved.
As a PhD student who received financial support from JRC, I'm very pleased to be involved in this series of experiments, working with researchers and engineers, and got promotions in both professional skills and cross-team collaboration.
The Joint Research Center faced many challenges, such as COVID-19 pandemic and the global economic depression. However, the JRC team jointly overcome these challenges and made great scientific contributions in the history of ocean renewable energy development. We are here today at Shanghai Jiaotong University State Key Lab of Ocean Engineering, witnessing and celebrating the milestone of this joint venture.
We have not only discovered new findings, but also designed and proposed new structures. The one that being tested in the laboratory is a great example. Furthermore, we have provided platforms to help young people to grow. from students to postdocs, and from postdocs to faculty members. In the next 5 years, offshore renewable will step from near shore, shallow water to far shore and deep water.